Hi there. Today I'm going to be talking to you about API benchmarks. So one of the things that really bothers me is that API benchmarks can come in a lot of different forms. I've seen benchmarks with people just today claiming that they can get 10,000 requests per second. And this is because based upon the data and how they're testing, they can get all sorts of data. And this is one of the reasons why I created the BeAPI Bench, so that you actually see how the test is happening and what is being tested. And I'm going to go over API benchmarks and why you see so many different fluctuations in API benchmarks and what this actually means, what an actual benchmark is, and why there are so many fluctuations, and what you should be looking for in an actual API benchmark. So let's take a look at a few of these real quick and go over some of this. So come with me.
Okay, so one of the pages that we're going to look at today is somebody did a API bench on PHP and Django and Node JS. And it was nice that one of the nice things that they did that a lot of people don't do is that they actually stated how many cores and the memory that they have. Now, memory doesn't really affect your API test that much. It's really the cores because everything is done on the processor for the most part. Memory does play a little bit into it, but it's mostly going to be your cores. Um, uh, Yeah, specifically the number of cores. So the fact that they laid that out is really, really important. You really, for your test, want to know how many cores are being used for the tests. So that's very positive. And they stated that it was a simple hello world. So again, very positive thing about these tests, so that you can tell um, what is really being involved in the tests. So bravo to these guys, Mihai George, in the fact that he stated this up front. It's very important that you state this. Unfortunately, in the fact that this is a Hello World test, he's kind of testing apples and oranges. So PHP Laravel and Lumen and Python Django and Java Spring and .NET Core, these are all frameworks which have a front controller. Now, a front controller handles your it's a pattern in MVC architectures which handles the requests and the response for a website. Now, these are all frameworks versus Node.js, which is not a framework. It is a very, very bare bones, more like a server. And then you can put a framework onto it. And Express really is not a framework. It just handles bare bones handling of web pages for the most part. JavaScript, CSS, HTML. And you have to build that out. So assuming that that is not built out and judging from these response times, it is definitely not built out. And you can see that in the comparison of the response times on these. They are not built out. And you can also tell that there's no security, there's nothing. It is just bare bones on all of these. There's nothing built out. It is simple hello world. And it's stated that it is very simple hello world application for all of these. So there's no security, there's no checking, there's nothing. It's just a page, hello world, being responded back for all of these APIs, which explains the response times on all of these. They're tremendously high, nothing is being done, and this is what you should look for. If it is this high on these number of cores, it is most likely that it's just a hello world on all of this. And there's no security, there's no checking, there's no cores, etc. somebody is lying to you. Same thing with this guy. And he even shows his work for the most part, but he does not show the number of cores and all that other stuff. States right up front, 10,000 requests per second on REST APIs or blah, 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 blah. Comes down here and he says, look what I did. I did this. I hooked up a query on REST Azure. And it's basically just a query directly to the database. What effectively he calls a controller is literally just tying it directly to the database. He's not actually creating a true controller. It's just tying it directly to the database. And there's nothing else. There's no security. There's no cores. There's no pre and post processing of the object that is returned. It's just a hello world. 10,000 requests. No telling us how many cores there are that he's using or anything like that. What instance it is within Azure. It's just 10,000 requests. Woo! This seems more like and he works for Microsoft, so that figures. This seems like it's some sort of spin job for Microsoft. So, yeah, I take this with a grain of salt, the size of a salt lick. So I really would not feed into any of these that show all of this. The first one was far better because he shows his cores and he shows the examples that he's using too. So he was very good, and you can see wherein he's getting he's mixing the frameworks with a bare bones Node.js. So it's a little off here, and I really wanted fault him too much on that. I mean, Java Spring and .NET Core, still they're getting really high times, but they're not doing anything. They're just returning a hello world. They're way off. I mean, I use Spring for my work too. I use Spring Boot, but this is not right. I'll tell you straight up. I test on a 4-core system where I even just give it 1 gigabyte. But this isn't right. So let me show you from here what your benchmarks should look like and how to do them properly using BeAPI Bench. So what I want to show you today is the BeAPI Bench tool, and this is what I use for API benchmarking. You can go ahead and download this off of GitHub if you'd like, and you can see the output here that it generates. It shows you the requests per second for each test, and in this, it shows the number of tests are 50. So it's a request per second for each of the 50 tests. First test was 1.52 seconds, and then this was like the fourth test was 0.96 seconds, and so on and so forth, going on up to the last test, the 50th test being 0.27 seconds, a total of 0.2 or 27 milliseconds, effectively, and or 270 milliseconds. My fault. And this other test is requests per second for each test, and the total seconds for all of the tests. So it took 70 seconds for all of the tests to run, and it shows you the total time over all of them. So it's a very nice slope up, and that's what you want to see for all of these, a very nice gradual sloping up. Once it starts topping out, that's where you know your optimal timing is, your optimal concurrency and requests are for your load balancer. And this is one of the things you want to check for too when you're doing your benchmarking. And you can see here the connection time. This was done, by the way, on a local host, and you can see that up ahead, or up at the top, URL localhost. and it was a simple get. And for the record, this was done with security and cores and pre-processing and post-processing and everything. So this is a full-featured framework. And we're actually going to go through and do one of these tests too. So I can show you how it works. But I just wanted to go through here and show you everything that you can do in the framework. You can set your concurrency, or I'm sorry, in the tool, you can set your concurrency, the requests, your token, get method, endpoint. And if you have any questions with how to run it, there's always a help tool in it to tell you how to run it. So let's go ahead and do that real quick. And I'm going to go ahead and start the API server up from scratch. And this is important because you want to see how it runs prior to caching of the endpoint, because you won't get a proper test if your endpoint has already been cached. So you want to do that prior to the cache. And we're going to do this, as you see, with 200 concurrency and 3,000 requests. And we already have our token preloaded. So let's go ahead and give it a test. Now this takes a long time, I will warn you, and I'm probably going to cut the video and go straight to the end. But I wanted to show a couple of these in the process. So it shows you the first test is 351 requests per second. Now normally, I'll show you up here, when I'm not recording the video, it will do 567 requests per second. So you want to run these tests on a headless system. You will also want to run these locally as well as across the network to get a good idea of how these are going to run. You don't want to run these on a system where you have a bunch of apps and everything up and running. You're not going to get a good test. Also, a test run on localhost is not an accurate test. But for seeing what it can do and how well it can benchmark and everything, like I showed before, to see where it bottoms out, it's actually a very good measure to show you where you're going to bottom out on the network, especially for a load balancer on the same network. That's why you will do it on localhost, to know where that bottoms out on the same network for the number of requests and for the current concurrency. That's why that's important to do on a localhost. To see, get an idea of how the traffic is going to go for load bound, or for just general traffic wise, when you want to move to another instance or what, you would do that on multiple across the network, not on localhost. Okay, so now the test is done, and you'll see at the very end, see results in BeAPI Bench.html. Now, if you downloaded the directory, if you downloaded or just cloned the file, it will be in your BeAPI Bench directory. And here it is. Let's take a look at that real quick. And you will see it is dramatically different, 0.43 versus what I had previously. Let's go to now here it is, 0.27 milliseconds. And that's because I had the video equipment, or I'm sorry, the video recording and the browser up at the same time. So it is dramatically slower. This is what I was talking about, how you want to make sure that all unnecessary processes are turned off when doing this, because APIs are very processor intensive, as I mentioned earlier. But again, it's very upward rampy. You want to see that upward slope. When it starts dropping down like this, that's when it's starting to hit it's beginning to top out, and you will notice it. It will just top out dramatically. It'll just go da, 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 and that's it. That's where you've topped out. Down here, you'll see the connection time. You should not see any connection time at all. Uh, you'll get this if your processor is being hogged by other things, which means shut down processes. You need to be shutting down processes. And the processing time and the wait time goes down dramatically once things have been cached. You'll notice right here, has not been cached, and then boom, caching has happened and everything just goes down. Same thing with the processing time. New threads start being spawned, and boom, all the threads have been spawned, and we're topping out. We begin to top out right here. Now, if I had kept the test going even further, you would see all these spikes here. I don't know why we had a failed request in the beginning. It shouldn't have happened, but no failed requests for the most part. I think this is a false positive. I did not see anything in the tests at all, but I can take a look at that. But yeah, there you go. This is the only thing I did not state in here is the number of cores. This is being done on, I believe, a 8-core machine. I'm only giving it 1 gigabyte for the entire thing. Scales up to 2 gigabytes. And let's see, what else? Yeah, it is Spring Boot with Grails. And it is a full-featured framework with security, tokens, authentication, cores, pre-processing, post-processing, and it can get approximately, if you look over here, 3,500, 3,800 requests per second with a full-featured framework. And that's what you should be looking at. You should be looking at all of the functionality being provided with the processor, with the number of cores, and how it ramps up with the concurrency and requests over time. This is the kind of test you should be looking at. People can just spout out a stat and say 10,000 requests per second. But if you don't see all the functionality as well, and here, let me show you a list of functionality that you should be looking at. You should be looking at, can it handle tokens? Does it do schema management? Can it do batching and webhooks and things like that? Or is it just doing direct APIs from the database kind of thing? It can't handle redirects and things like that. Does it do throttling and rate limiting, which naturally you're going to be turning off during any kind of benchmark. API docs. Naturally, you're going to have caching. Otherwise, it's not really a benchmark. But things like that. All of this are things that are going to slow down any kind of API benchmark. Otherwise, it's just a hello world. But these are things that you want in anything that you're going to deploy. So look for that kind of thing. Look for the cores. Look for the memory. Look for the functionality. Otherwise, it's just a simple hello world that they're testing. And it means absolutely nothing, and you should just disregard it. Again, thanks for watching. If you have any questions, please post.